You guys can watch it again if you need to, but the first thing in this probability, oh, I'm on the wrong one, sorry. First one is expected value. Okay, so expected value, this first is called a probability distribution. When we have, like, you're taking a 5-question quiz, so you could either get 0, 1, 2, 3, 4, or 5 questions right. So the probability of getting that many questions right, depending on how you study and stuff like that, this probability distribution always has to add up to 100% or 1.00. So anytime you're given a probability distribution, those probabilities have to equal 1. So that's what the first question is. Just what's missing right here? What's this number so that all of those will equal 1? So I will add up everything that I know, and the 0.22 with my calculator on Desmos, 0.18, 12, 15, 8, 22. That adds up to 0.75, and then if you subtract from 1, you end up with 0.25. So what is the missing value? 0.25. And it says 2 decimal places, so that will be the answer. You have to type in your answer. It's not multiple choice. When you type it, you can do 0.25 or just 0.25. All good. So that's what the first one is. Just all probability distributions make 100%. The second question is about the actual expected value. Well, when you have a probability distribution with values, so up here are your values, here are your probabilities, then you can get what's called an expected value. And that is, if you did this a bunch of times, if you took 100 kids, took this quiz, then what's the average that they got right? Right? It's not, there's a big difference between, well, first, since this is missing, I'm going to have to find it. So I'm going to add up what I know. So it's going to be 0.06, 0.11 plus 0.15, 0.20 plus 0.34. That adds up to 0.86. So 1 minus 0.86 is 0.14. So this is 0.14. Okay, so the expected value, like I said, if 100 kids took this quiz, what's the average grade? So it's not necessarily going to be a 1, 2, 3, 4, or 5, because when you find the average, you end up dividing. Right? So to get that, it's always the same process. You take the value, so the first value is 0, and multiply it times its probability, 0.06. Take the second value, 1, times its probability, 0.11. 2 times its probability. 3 times its probability, plus 4 plus 5 times 0.34. That's how you get expected value. You multiply and add them all together. So 0.06 plus 1 times 0.11 plus 2 times 0.15 plus 3 times 0.14 plus 4 times 0.20 plus 5 times 0.34. And it ends up being a 3.33. 3. So 2 decimal places, there's your expected value. In other words, if theoretically, and I was talking to you yesterday about this is theoretical probability. Theoretically, if 100 students took this test, the class average should be a 3.33. Now, can you get exactly 3.30? No, but that's just an average. So that is the expected value. So on the next ones, they don't give you the probability distribution. You're going to have to come up with it yourself, and it's not too bad. And remember, you need values and you need probabilities to find expected value. So a bag contains 12 $1 bills, 8 $5 bills, 5 $10 bills, 1 $20 bill. If you get to choose one at random, what's the expected value of the bill? Well, the values of these bills are $1. You have a $5 bill, $10 bill, and a $20 bill. And there are 12, 8, 5, and 1. There are 26 bills in total, right? If you add up the total number of bills, 12 ones, 8, 5 10s, and 1, so there are 26. So the probability that you reach in and get a $1 bill is 12 out of 26. There are 8, and don't worry about reducing these. It'll make much more sense if you leave them not reduced, because now if you add them up, it's easy to add up. That should add up to 26 out of 26. That should add up to 1, like I said. So once you have your bills, your expected or your probability that you draw each bill, the expected value for one of them is multiply the value, that's the probability, times the probability of getting a 1, plus the $5 bills, the probability is 8 out of 26. Getting a $10 bill, the probability is 5 out of 26. And getting a $20 bill is 1 out of 26. And then you can put that into Desmos for your calculator. 1 times 12 over 26 plus 5 parentheses 8 out of 26 plus 10, 5 out of 26 plus 20, 1 out of 26. And it says round to the nearest hundredth, 2 decimal places, right? So that would be 4.69 for this one. Now, can you reach in and get $4.69 out? No. But if you did this over and over 100 times and figured out the average money that you got out, that would be what it is. So expected value. Now, if I put a price on this game and I said it cost you $5 to play this game, well, this isn't a great game. You're going to end up losing money in the long run, right? Because you're going to pay $5 and end up getting $4.69 every time. But if I told you it costs $4 to play this game, well, then yeah, this would be a good game to play because you're making money. This is a better expected value than what it cost. So that's how expected value helps us with games and probability and stuff like that. All right, so the next one is the same idea, just a different setup. It's a carnival game. It has 60 slots and there's red, green, blue, and black. So make your probability distribution red, green, blue, and black. Those are not values. So I still need the value of each one of those. And then it's probability. So it says, if a player lands on red, he loses $5. So if you lose, that's a negative value. If a player lands on green, he wins $2. If a player lands on blue, he wins $10. If a player lands on green, he wins, and if a player lands on black, he wins $20. So that's the value of each one of these colors. The probability comes from if there are 60 slots, if 30 of them are red, 30 out of 60. So this one you don't have to count them up because it tells you. 15 out of 60 are green, 10 out of 60 are blue, and 5 are black. 30 and 15 is 45, 55, so that does add up to 60 out of 60 if you want to check it. But what's the expected value of that game? So it's the value times its probability. You're going to lose $5 30 out of 60 times. You're going to win $2 15 out of 60 times. You're going to win $10 10 out of 60 times. And you're going to win $20 $20. My voice just cracked. You hear that? And I recorded that too. All right, 5 out of 60 times. Calculator, and that's your expected value. -5, just make sure if it's a loss, you include a negative. 30 out of 60 plus 2 times 15 out of 60 plus 10 out of 60 times, and 25 out of 60 times. So this has an expected value of 1.33. So if you think about this as a game, this is a good game to play because you're expected to win more than you lose. You're expected to win $1.33 every time you play it. If this was a negative value, that would be expected to lose. So that's it. That's expected value. So number 5, ask about a fair game. Well, a fair game would be a game that you're not expected to win or lose at the end of it. That it turns out to have a 0 expected value. Or, in this case, okay, so another game, but this one has 100 colored cups that red, blue, green, yellow, and black. This has 5 different colors. There's red, blue, green, yellow, and black. The game costs $5 to play, and if a ball lands in a red cup, nothing is won. So the value of a red cup is 0. If the ball lands in a blue cup, $2 is won. If the ball lands in a green cup, $5 is won. And if the ball lands in a yellow cup, $10 is won. How much should, so the question is, what should we make the value of this black cup, the one black cup, so that this is a fair game? Well, because the game cost $5 to play, then we need the expected value to come out to be $5 in the end. And that way, when you take away the $5 you cost you to play, that would give you a 0. Now we could have adjusted these values to the $5, but we'll just leave those the same. So 50 out of 100 are red, 25 are blue, 15 are green, 9 are yellow, and 1 is black. So I want to go ahead and do these first. The 0 times 50 out of 100, which of course is just 0, to 25 out of 100, 5 times 15 out of 100, and 10 times 9 out of 100, right? And then there's something else going on before it equals 5, but let's just get that first. So if you multiply that out, 0, 50 out of 100, 2, 25 out of 100, plus 5, 15 out of 100, plus 10, 9 out of 100. That comes out to 215, right? So plus some value that is going to be, I don't know what, times 1 out of 100. So that'd pretty much be x over 100. And you want that to equal 5. Or you want x over 100 to equal, if you subtract the 215, right, from the 5, you get 285. 2.85 times 100 is 285. So this needs to be $285 to make it a fair game. And it's a lot because, think about it, all of these are actually, well, this one makes no money. These two, 75% of the time, you would lose money. You'd lose $5 here, or you would lose $3 here. That's why this one, that one time, has to be such a big amount. All right, so find that expected value first. Remember, it's got to equal 5. So, all right, and then the last one is, because we're finding averages, this one gives you your whole table. It'll ever switch. Okay, so Jim's playing a card game. So his points are -3, 0, 2, 5, 10, or 20. There's the probability of getting those points. It says if the game has 30 rounds, how many points can you expect him to get? Well, first, what's the expected value? In other words, how many points is he going to get for one round on average? So plus 0, 4 out of 25, plus 2 times 4 out of 25, 5, 2 out of 5 times, 10, 1/5 of the time, and 20, 1 out of 25 times. To get that expected value, multiply all those out. So -3, 1 out of 25, plus 0, 4 out of 25, 2, 4 out of 25, plus 5 times 2 out of 5, plus 10 times 1 out of 5, plus 20, 1 out of 25. So that expected value is 5. So he can expect, playing this game, that he's going to get 5 points for every round. So all you have to do is, if he's going to play 30 rounds and get 5 points every time, then we can expect he would score 150 points. So anytime you have an expected value question, they ask you what's going to happen if they do it 10 times, 20 times, whatever. Just multiply your expected value times the number of times you would play the game or do the rounds. Questions on those?